Between the years 1911 and 1919, Srinivasa Ramanujan, a very famous Indian mathematician, posed a total of 58 questions to the Journal of the Indian Mathematical Society. Now, when a mathematician of the stature of Ramanujan is going to pose any question, it's not going to be an easy question, right? So the question that we have at the front of the thumbnail is one of the questions that Ramanujan actually posed. The objective in this video is not to say, here's a really hard question posed by Ramanujan and can you solve it? In fact, to the contrary, what we want to say is that even when you have a tricky or a difficult question, and a question which is posed by Ramanujan, if you think about the question a little bit, right, if you're slightly patient with the question, we can actually make progress, and progress is good. So what we want you to do is get yourself some paper, get yourselves a pen or a pencil, and think about how you might make progress with this question. And if at the end of this video we can at least walk away with a conjecture on what we think the solution is, that itself would be absolutely great. So we'll be back after the pause, working our way through this question. In the meantime, please think about it. Let's recall that roots are written using the radical symbol. Okay, so using the radical symbol. So the radical symbol is written in this way. So you'll be familiar with the square root sign. So that's what you recognize as the, so let's say is the square root of x, or we can have the cube root of x. So the question that we have here is related to a nested radical. That's the question. So we have a nested radical, and a nested radical is a radical within a radical. So for example, if we had the square root of x plus the square root of x, and that's an example of a nested radical. So the question that we have is the following. So the question that we have at hand is the following. Can we evaluate 1 plus 2, and you have a square root sign on top of that. So you have 1 plus 2 times the square root of 1 plus 3 times the square root of 1 plus 4, and the pattern continues. So the question that we have is, can we evaluate this nested radical, and we want to know what this is actually equal to. So this is the expression that we are meant to evaluate, and looking at it, it does look slightly daunting. It does look slightly difficult in terms of how do we actually make progress. Now, one simple way of making progress is to just start evaluating this numerically. Okay, so we can actually start evaluating it numerically, and so let's do that. So if we do 1 plus 2 and evaluate that, we'll get 1.732. If we do 1 plus 2, 1 plus 3 square root and take the square root of that, we'll get 2.236. If we take the next term in as well, we do 1 plus 2, 1 plus 3, 1 plus 4, and if you sort of punch that in through a calculator, you will get 2.559, and we can keep evaluating this expression, and if we do that, we find that the next number turns out to be 2.755. The next term turns out to be 2.867, and the next term turns out to be 2.929. Now, what we notice here is that this sort of sequence of numbers that is coming seems to be approaching 3 quite rapidly, right? So maybe we can guess that this expression here is actually, let's say, less than or equal to 3. Right, so that's something that we're just conjecturing. I mean, that's just based on a numerical analysis of few of the terms out here. We see that the terms are seem to be rapidly approaching 3. So let's assume that it is actually bounded by 3. So it's either less than or equal to 3. So let's explore what actually happens with 3. So 3 is just the square root of 9. 9 is 1 plus 8. 8 is 2 times 4. 4 is just the square root of 16. 16 is 1 plus 15. So that's 1 plus 15. 15 is 5 times 3. So that's 1 plus 2. 1 plus 3 times 5, and 5 of course is just the square root of 25. So we have 1 plus 2 and 1 plus 3 and the square root of 25. Okay, so there's a little bit of a pattern which is forming here. Let's explore it a little bit more. So let's look at the square root of 25 in a little bit of detail. So the square root of 25 is just 1 plus 24. Now 24 is 4 times 6, and 6 is just the square root of 36. So that will be 1 plus 4 times 6, but 6 is just the square root of 36. So we can write it in that fashion. Now 36 is 1 plus 35. So you have 1 plus 4 square root of 1 plus 35. 35 is 5 times 7, and 7 is the square root of 49. So we get 1 plus 4, then you have 1 plus 5 times 7. So you have 5 times 7, but 7 is just the square root of 49. Okay, so you see there's a fairly regular pattern which is showing up here, and it gives the impression as if 3 could well be the answer, and in fact 3 is the answer. So the answer is in fact 3. Now what you need to do is you need to try and prove it. Okay, what we've essentially done is just provided a conjecture. It looks as if the answer ought to be 3. We're telling you that the answer is in fact 3, and what we want you to do is now think deeply to try and prove that 3 is indeed the answer.